CBM Exploration and Exploitation. I heartily welcome our chief guest, Dr. Vilas Tavade, MD and CEO at SR Oil and Gas Exploration and Production Limited, for sparing time from his busy schedule and gracing the occasion. I welcome all honorable speakers, Professor Mrinal Sen from UT, University of Texas at Austin, Dr. Sumit Verma from University of Texas at Permian Basin, Dr. Ashish Kumar, COO of SR Oil and Gas Exploration and Production Limited, Dr. Robert Trentham, University of Texas, Permian Basin, Professor M. Bhagigi from Australian School of Petroleum, University of Adelaide, Dr. James Peter, ex-GGM ONGC, Dr. B. M. Mendhe from CSIR, Simpar Dhanbad, Dr. B. K. Prushti from IIT Kharagpur, Mr. Mukul Srivastava from RIL, Reliance Industries Limited, Mumbai, Dr. Son Dang from Oklahoma, Mr. Krishnendu Chatterjee from SR Oil and Gas Exploration Production Limited, Dr. Roderick Perez, President, Sentia Group, Colombia, Dr. S. Bhattacharya from University of Alaska, Mr. Abhijit Biswas from DGH, Government of India, Mr. Akash Sharma from Austin, Texas, Ms. Sridevi Bale from Accenture, Bangalore, India, and Dr. D. M. Tiwari from University of Hyderabad for contributing in this workshop. This workshop has also received very good response in terms of registration and participation by more than 1,600 delegates, and I can see the numbers rising. Online participation, it is already 511 now. I heartily welcome all participants to this workshop. This workshop is a two-day event with several interesting and informative sessions on CBM, reservoir characterization, exploitation techniques, new technologies, and panel discussions and brainstorming sessions. With technology intervention, shale gas holds the key to fulfillment of energy requirements. I'm sure that sharing of ideas by our esteemed speakers, panel members, panel discussion and exchange of thoughts by participants in this two-day workshop will be very useful to the cause of shale gas exploration and exploitation. I again welcome you all to this workshop and wish you a very productive time today and tomorrow. Thank you. Yes, Dr. Annapurna.
Thank you, Dr. Khare, for welcoming our panelists, our speakers, our chief guest, and all the participants. Now, I would like to introduce our chief guest, Dr. Vilas Tavade. Dr. Vilas Tavade, Managing Director and CEO at SR Oil and Gas Exploration and Production Limited. Sir is graduated from College of Engineering, Pune with a bachelor degree in engineering in instrumentation technology. Mr. Vilas Tavade has worked in ONGC at various assignments. He then was appointed as General Manager at SR. He demonstrated his skills and rose up the ranks by being appointed as the Head Commercial Operations at SR Exploration and Production Division. He is now Managing Director and CEO at SR Oil and Gas Exploration and Production Limited. Sir is a leader who performs well in the diverse environment, experience of managing all phases of project life cycle, especially unconventional hydrocarbon field development in India, right from pre-feasibility to complete field development. I welcome you, sir. I welcome you to this 2 days workshop, international workshop on shale gas and coal bed methane exploration and exploitation. And I would like to request you deliver inaugural speech. Sir, kindly unmute your mic. It is muted.
Yes, thank you and welcome the August gathering over here. I see Dr. Peters, who is a partner in our CBM development, Dr. Hegigi of from Australia. We shared a co-chairman. I will just share one slide which gives the importance of unconventional gas. So Annapurna, I'm going to share a slide. Okay.
Yes, sir.
Just confirm whether the slide is on the
Yes, we can see
screen.
it.
Yes, yes.
We can see it.
So as I welcome again all the August gathering, thanks for UPS. It's a very good response they have got from all over the world globally. And probably COVID has taught us many lessons in terms of organizing webinars, seminars, conferences. So I believe basically we, as a fuel, we are moving from fuel wood to hydrogen. So I call it the transition of fuel from CH. So if you see the top transition, we started with fuel wood, and then we are migrating towards hydrogen. Probably people say that 22nd century will be a hydrogen century, and during this time from now to whenever the hydrogen fuel is economically, commercially viable, which is a sustainable form of energy. So as we all know, hydrogen is emission of hydrogen is water, and from water you can generate hydrogen. So that becomes a sustainable form. So from fossil energy, we are moving towards sustainable energy, and the transition, the the gap or the bridge from fossil to sustainable, I believe, is a gas as a natural phenomenon. So CH4 is the cleanest fuel next to hydrogen. So we from now onwards to probably 22nd century, probably I don't know, maybe 70, 80 years or 100 years from now, it will be a sustainable form of hydrogen energy. We see as gas, and mainly because of the depletion of conventional gas reservoir, unconventional gas will be the bridge towards the sustainable energy. And now that CBM Shale has been established globally in USA, in China, Australia. Australia, of course, CBM Shale has to be established, and partly in India, this CBM Shale and in future gas sided is going to play a major role. So this is where all the fraternity has to focus, which also helps in terms of the global CO2 emission, bringing it down. If you just compare, methane gas gives 0.189 kg of CO2 per unit of power generated, whereas the crude oil, or if we refine crude oil, gasoline, etc., are in the range of 0.25 kg per kg CO2 per unit, whereas the coal is almost 0.33. So the cleanest form of energy available next to hydrogen is methane, CH4, and hence as a responsible fraternity to the planet, we should focus on three aspects of the unconventional. One is availability. Yes, we have to check the availability, the resources available. Second is affordability. How economically we can extract these resources and deliver to the customer. And the accessibility. Accessibility is what the federal government or the state governments have to do in terms of developing the grid pipelines across the country. There has been a lot of focus in India specifically on this. So the main aspects, what I was saying, that Asia is has emerged as a strong demand. I will focus on Asia because a lot of participants are from here. India among them is in globally we are third largest energy consumption, and we are highly dependent on fossil fuel import. In terms of our energy security, Prime Minister has given a vision of 10% import reduction, where I believe if we strive a coherent approach. Probably 2 to 3% can be contributed by unconventional gas. And then there is a high target of conversion of gas-based economy in the country from right now from 6% to almost 15% by 2040. So these are the targets set by the federal government, moving towards a cleaner fuel in both in terms of carbon emission and of course extraction of methane from the mines prevents the methane emission to the atmosphere, which is almost as on date 34 times more potentially hazard than CO2. So considering the COP21 and COP24 commitments, probably it will be on in implementation stage within a year or so. We should all focus specifically with respect to India and globally in terms of climatic challenges which we are coming. So the challenge to the fraternity is, of course, uh, establishing the availability of these resources in the country and globally, and make it affordable to the alternate fuel which are available now, so that maximum usage can be done. I thanks again for all for the UPS for organizing such a good seminar with all the major institutes involved in unconventional gas, including SIMFER, CMPD, etc. And I wish all the best to the conference and declare the conference inaugurated. Thank you very much.
Okay. Thank you very much, sir.
Over to you, Aparna.
Thanks.
Yeah.
Thanks a lot. Thank you, sir, for sparing time out of your busy schedule and for sharing your wisdom word to the audience. We are delighted to have you and have your kind presence to inaugurate this joint initiative of UPES and UTPB, University of Texas Permian Basin. So now we have Arun Singhal sir also. I welcome you, sir, from Dew Journal. I would request Dr. Penuli sir to say few words to the audience, to the participants.
So good morning, everybody. And I was supposed to give the vote of thanks at the end, but you asked me to thank Vilas. So this is all right. So this is a great initiative by the Petroleum Engineering Department and Earth Sciences, headed by Sunil Khare, and the key driver is Dr. Annapurna herself. She did a very fine workshop on CBM and conventional resources of petroleum for Isar oil, sometimes back in 2 months back, and it received huge response actually from the industry. So we UPS and we liked that idea and thought, why not do it a global workshop on unconventional resources, which is shale oil and the CBM. So that is why this team, the whole panel is here, and parallelly the panels taking place in the North American side in the afternoon is a jam-packed event with almost experts coming from the industry and the academia. Vilas Taure, one of the great guy to my mind in CBM, because he's the leader of a company who has spent billions of dollars in exploration and exploitation of CBM in India. Probably the torch bearer besides some of the PSUs like ONGC. And James Peterson, he has great experience coming from ONGC, operating and managing the gas fields, both conventional and the unconventional. So he's just because this is probably I'll be talking at the end. I'm going to thank everybody, especially Vilas now, for his very astute lecture, because he brings a lot of information to a lot of content in terms of the challenges and the policy imperatives that the government of India has formulated to to kickstart and enhance the natural gas production from unconventional sources. Dr. Hege is a great friend of us, particularly my personal friend and the friend of UPS now. So great to see you here. With these few words, I'm giving back to Dr. Annapurna to
Thank you, sir.
speak, please.
Thank you, sir. So we are going to start our first module. So I'll give a brief introduction about our first module. Sir, can you see my PPT?
Yeah.
We can see it.
Okay. So I welcome all of you, and in the first module, okay, so we have divided this workshop into 4 modules. First is on coal bed methane, and lectures will contain exploration, production, history and challenges, wellbore stresses and case studies. Second module will include reservoir characterization using different techniques like seismic, petrophysics, different imaging, multi-scale imaging techniques, advanced techniques like NMR. Then third module will include exploration techniques, exploitation techniques, machine learning, geochemistry, adsorption, desorption, hydrofracturing. Then the last module will be new technologies on digitalization, new technologies, novel information, novel technologies related to geophysics, and CO2 enhanced gas recovery for shale gas and CBM. So today we are going to start our first session of the first module, and the session will be delivered by Dr. Hagigi. He is Associate Professor at University of Adelaide, Australia. Sir is graduated with combined BSc MS degree from University of Tehran in Chemical Engineering, then Master and PhD both in Petroleum Engineering from University of Southern California. He was project director at National Iranian Oil Company. He worked for almost 9 years as associate professor at University of Tehran. He joined University of Adelaide as associate professor in 2009. So I welcome you, sir, to deliver your wisdom talk, to deliver your knowledge on effect of matrix shrinkage on wellbore stresses in coal seam gas, an example from Bowen Basin, East Australia. Sir, please start your presentation. Okay, sir, your mic is mute. Can you unmute your mic?
Oh, so I should start from the beginning. Yeah, I'm very happy that I was invited by UPS to participate in this workshop. Thank you for your introduction. As Pramod mentioned, now I'm a friend of UPS, and I'm very happy that we are collaborating in some academic activities. So for this workshop, I would like to talk about a big problem of fine production, you know, like a sand production. And in Australia, these days, most of this drilling is going to be horizontal. And I will show it to you that during the horizontal drilling and also in vertical drilling, one of the challenges is fine production, which is not good for you know, production. Also a lot of environmental effect, and pumps will be eroded, pipeline will be eroded. You know that, you know, solid particles production with gas or water is a very bad thing. So I'm gonna present this topic, coal failure analysis, which shows that how we can predict this failure or sand or coal fine production. And in this presentation, this is an example from Bowen Basin in East Australia. Yeah, this work basically, let me go to, okay. This is the work from my PhD student, Reza Zare. Also, I'm going to acknowledge the work by Dr. Abbas Haksa from Baker Hughes in Australia that they contributed in this work. So as an introduction, you may know Australia is very active in coal-bed methane and is the second place. Most of the production is from Bowen and Surat Basin in East Australia, in Queensland, in also New South Wales. Almost, I would say, all of these, most part of this production is going to be LNG, partially for domestic demand, is going to be increased by 1,850 billion cubic feet per year by 2025. Until 2015, 8,500 drilled has been 8,500 wellbore has been drilled, and there is a projection for up to 40,000 wells eventually be drilled until 2025. This is some statistics and backgrounds from this activity. So the problem with fine production, as you know, like a sand production, similar to sand production in conventional reservoir, in CBM, a lot of erosion of choke, pipeline, pumps. In addition to this one, also flow line fill up and reduce the capacity. Also, if you look at this, we have a separator fill up, a lot of downtime and disposal problem. In addition to this, production problems, loss of integrity behind casing when you have when you have coal fines, and also well fill up. This is also reduce productivity index. So these are all the problems and challenges exist with this coal bed methane production. So again, we know that the reason we have this issue in coal bed methane because coal is softer rock and is susceptible to fail during production because of the shrinkage effect. You know that after desorption of gas from the coal, there is a shrinkage of that coal block. And this is going to be, I will show it to you. This is very important, especially in horizontal there. It happens everywhere, we had reports, a lot of reports in coal failure in San Juan Basin, when pore pressure below 250 psi, and there was a bad effect is that permeability reduction because of this. Also, there are reports of serious well instability during drilling and production in China, Qinshui Basin in China also. So you will see that this is a kind of global problem for coal bed methane in everywhere. So in order to okay, again, some problems in Australia, as I mentioned, this problem is more important when you have a deviated or inclined or horizontal well. Why, I will show it to you later, but now in Australia, deviated wells also a key part in Surat Basin. We had 12 multi-well pads with 60 deviated wells, and majority of these failure goes to this reservoir and fluid issue. Arrow Energy reported a majority of artificial lift failure, like a pumping. You have submersible pump for dewatering and all type of pump. This is they fail due to solid production into the wellbore. Really is an economical and also environmental issue for most of the companies involved in CBM. Coal failure during drilling and production from horizontal well in MCM. MCM in Bowen Basin is a case that I'm going to show it to you in this presentation. So, what is the reason? If you want to analyze and find out the reason for this early fine production in CBM, we should look at the stress relationship and also a stress path, which shows that how stress is changing with pore pressure, which is production. During the production, of course, total stress, as we know based on this relationship, for vertical stress is not changing. During the production, when pore pressure decreases, horizontal stresses decreases. But this is total stress. When you look at the effective stress, which is stress minus pore pressure, and also you see that both vertical stress and horizontal stress are increasing during the production. So this is for conventional reservoir. This is happens in conventional reservoir. If you look at the stress envelope during the production, when pore pressure decreases, you see that the vertical stress originally goes to the right, and also horizontal stress and this black side goes to the right. But of course, as you see, the slope of these changes is higher for vertical. You see the vertical stress is higher. The increase of the vertical stress is higher than increase of horizontal. So in this case, during the production, we see that this envelope is larger and larger, and eventually you see that it comes to the failure. This is the stress path in conventional reservoir. When you have an unconventional reservoir like a CBM, we have this extra term of shrinkage effect. Basically, this shrinkage effect, this is a strain, and these are basically Longmire relationship. This is Longmire pressure. This is the original case. This is the current case. So when you add and consider this shrinkage effect, you see that the stress path is changing. Of course, this is total stress, and then this is effective stress. So unlike conventional reservoir, for CBM, both horizontal stress, maximum horizontal stress, minimum horizontal stress are decreases. rather than increases. And you see that in this envelope, these are original stress. This is principal stress originally. Then after production, vertical stress increases to this, but horizontal stress decreases. You know, unlike this one, which both of them are increases, the other one decrease. And the resulting of this decrease and increase, you see that this circle is larger and larger, and you see that very soon we'll reach to this strength of the rock, which is usually low. I would say a coal is much lower compressive strength. In other words, this intercept for coal is very small, and also the slope is also smaller. So based on this analysis, we know that if you include shrinkage effect, failure will start sooner. So we are trying to develop a mathematical model and analyze this in order to predict the onset of this failure and optimize the production. We don't want to reach to this. I'm going to show you how this mathematical model developed for coal bed methane. As you know, we know that all rocks, elastic rocks, are stresses are uniformly distributed. But after drilling, when we remove the support of this, obviously stress distribution is not uniform anymore, and we have the maximum stress at the wall of the wellbore, and there is such a distribution, a new distribution of the stresses. So I'm gonna show you how this new distribution of stresses after drilling looks like when you have a CBM. So basically, in order to analyze this redistribution, we need to convert all these far field stress, principal stress, to cylindrical or circular geometry to see how's the stress at the wall of the wellbore and very close to the wellbore. So these are the result of the, as you know, you may familiar people who knows the geomechanical background. When you convert those principal stress to radial geometry, and also we want to also include the inclination of the wellbore. Not necessarily the wellbore is vertical anymore. We may have deviated or even horizontal well. So in generally, these are the formula for radial stress and also tangential stress or UPES stress. So when you convert those far field principal stress to this one, we have relationship of R, sigma R and sigma theta as a function of R. R is the distance from the wellbore. When, for example, R equal to RW, RW is the radius of the wellbore. When R equal to RW, it is at the wall of the wellbore. So based on these two relationships, obviously, that we want to include shrinkage to this formula. We know that for maximum horizontal stress or minimum horizontal stress, delta sigma h or is equal to this related to the pore pressure and shrinkage effect as well. This is the Longmire relation. So there is an extra stress because of this strain. A strain or shrinkage of the coal and create additional stress for horizontal stress. Of course, vertical stress we are assuming to not to be changing. So and also when you consider different type of wellbore, not vertical, you know, these are relationship. Alpha is going to be inclination from the when you have a vertical, of course, alpha is 0. When you have a horizontal, this is like a inclination or inclination angle. So so based on this formula, we want to apply this one to a case study, which is the Bowen Basin in Australia. Our case study, this is the Bowen Basin is in Queensland. This is Australia. In the east of Australia, we have Queensland, and New South Wales is our Sydney, and Victoria is in Melbourne. South Australia, we are here in Adelaide, is somewhere here. So our all activities of CBM in Australia is in two basins, Bowen Basin and Surat Basin. And Surat Basin, as you see, it is in Queensland and New South Wales. Actually, this is the stratigraphy of the our case. You know, we are going to show our case study is in Moranbah coal measures, which is the late Permian coal in this area. So we collected data for this case study from some wellbore. There were 3 wellbore in that one in Moranbah, KW1, KW2, KW3. There was some 1D earth modeling was already developed for these 3 wells. We use it, and also we used all these parameters for our mathematical modeling from different references. As you see that the SV is highest, so it's a normal stress regime. Of course, we have in other works, we have shown that how a situation looks like in strike slip or reverse faulting, but in this case is a normal faulting, and pore pressure is this. Other parameters, as you can see, is related to that case study. So I'm going to show you the result of this that shows how sigma r is changing with radius and distance from the wellbore. When r equal to r over rw is 1, it is at the wellbore, and this is 10 times of the wellbore. This theta is from 0 to 180. Actually, we can draw from 0 to 360, but now just half of them. And sigma r, we can see that is the minimum at the wellbore. And also if you look at that mathematical model, we put all those numbers to that mathematical model. We showed that sigma theta is the maximum at the wellbore, unlike this sigma r. And if you look at both of the sigma r, this is sigma r and sigma theta, we see that sigma theta is the maximum and sigma r is the minimum, and the highest difference is at the wellbore. This is the, when r w equal to 1, this is the wellbore. When you go far from the wellbore, you see that these differences is lower and lower. Eventually, very far from the wellbore, it's going to be just a constant difference. So this is the result of that mathematical modeling. Now, based on this stress analysis, we want to predict the failure. How's the failure in the situation? So based again, I showed you before that total stress is gonna decreases for horizontal stress, but it's gonna be total stress. This is for conventional. Basically, when there is no shrinkage. If there is no shrink, we can see, compare total stress when we have shrinkage here in right hand side with no shrinkage in left hand side. We can see that when you add this effect of shrinkage, this decrease of horizontal stress is much higher. You should, unlike these two, we have a large and also continuously changing. So then we used our mathematical model to predict how the sigma r for different pore pressure. The black one is when you have a 0 pore pressure. This is going to be when. So you see that when there is no shrinkage, sigma r is this one. But when you have shrinkage, of course, there is a more different separation from this one. But now sigma theta is more important. Sigma theta, when you don't have a shrinkage, almost all of them the same. Of course, we can see that when you have a higher pore pressure, a little bit higher, and then it becomes lower. This is at the wellbore. This is 1.5 around the wellbore. And sigma theta, in the case of shrinkage effect, we see that there is of course, a decrease and a lot of separation between these different pore pressure. So I'm gonna show you that again. This is for so we actually, I didn't have time to show you that after we calculated our stresses in radial geometry, then we need to again calculate the principal stresses in order to analyze the failure, cold failure. I'm gonna just show you the final, result of this coal failure analysis. Then this is the case. Basically, this is the failure point. We call it maximum coal-free drawdown pressure. So this is very important because when you go beyond that one, definitely you have a failure, and sand production or coal production. If you want not to have East coal production, your rate or your bottom hole pressure should be lower than this one. So this is the case for when you don't have no shrinkage, but when you consider shrinkage effect, you see that these failure points. This is the failure points, as I mentioned, is the maximum coal-free depletion pressure, or just the failure point, versus inclination of the wellbore. Zero inclination means that this is for vertical well. So all these points in this vertical axis is vertical, and when this inclination is 90 degree is for horizontal. So just you can compare these points in the right vertical axis to the points that to the left. This is the vertical, this is horizontal. Obviously, you can see that these failure points, it happens very low pressure, even for horizontal. And this is also a good confirmation with in reality. In reality, also in horizontal drilling, a lot of companies now have facing issue with the fine production, even at the very beginning of production. And yeah, this is I don't know how long I have time, but this is the end of. So yeah, this is again a comparison of both of this is the comparison of the both no shrinkage with the shrinkage, as I explained to you, that definitely shrinkage. So in coal seam gas, not only we have a shrinkage effect is important, but also coal in general is very soft and has a more potential for. So this is my conclusion.
Okay, thank you, sir. Sir, we have lots of questions in the question and answer box. I will read the questions, and sir, kindly you have to answer it. So one question is from Somyajit Mitra. Why is del sigma h is equal to del sigma small h?
Yeah, that's a good question. It shouldn't be that one. We just assume it as a, because in this, let me just go to that. Yeah, just this is our assumption that we know that here for simplification, we just assume it, but we know that we should calculate it. In other, when you are developing in current work, we are now calculating for real maximum horizontal stress and minimum horizontal stress when we are far from the build. But this is for this case, this is just an assumption.
Okay, so if you got your answer, then you can type it here. Yes. Then Second question is from Subhasis. Okay, I missed one question. Is from Rahul. How to effect stress on vertical borehole wall? How to effect stress? How, I think his question is how stress can affect on vertical borehole wall.
Yeah, that's as I showed. You know, this. Let me go to the last. The most important effect is the, you know, here. This is inclination. When inclination 0 is a vertical, and when the inclination is 90 is horizontal. So vertical wells, basically, there are higher. We can go higher bottom hole pressure during production. We don't have such a, you know, coal fines production in vertical wells, similar to the horizontal wells, which is the, as I showed to you. So sometimes you know, I had a conclusion here that sometimes matrix shrinkage in vertical well could help the stability of well force. So according to this one, yeah, that's my answer.
So next question is, sir, when the reservoir is more ductile in nature, how the vertical effect stress is related to the horizontal effect stress? So when the reservoir is more ductile in nature, how the vertical effective stress is related to the horizontal effective stress?
Yeah, yeah, I just show that the relationship between vertical stress and the horizontal stress, that, you know, when we have a, you know, desorption and also shrinkage, we need to add this parameter in addition to, you know, in addition to the, you know, this Poisson ratio and, you know, pore pressure, we have this shrinkage effect. I don't know, I think, or maybe this one also shows better that I showed to you that when we have a conventional, obviously this is the stress path for conventional. When we and the stress path is, and then this is the stress path for coal bed methane, which is obviously completely different.
Okay. Sir, we have another question from Dr. Dharmendra Kumar Gupta. He is professor from UPES. And his question is, under what circumstances shrinkage effect to be considered?
I mean,
under what circumstances?
Yeah, that I think it depends on this parameter that we have in shrinkage effect. As you can see, it has a strain of the shrinkage, and also depends on this desorption pressure. This is current pressure. This is the initial desorption pressure. This is current desorption. I think one of the factors is just long mirror isotherm. Maybe, you know, if you are in the, you know, if you look at the long mirror isotherm, later on, this long mirror isotherm is a kind of exponential shape. So later time is going to be more effect in this shrinkage effect rather than, you know, early time. Early time, you may be desorption curve or long mirror isotherm is not changing that much. This is my understanding.
So why is there a more decrease in vertical stress than horizontal stress?
Okay, if you want to know why, I should go to this mathematical. I'm sorry. This yeah, this is the mathematical modeling. As you see, this sigma r, for example, is a function of sigma x0. What is sigma x0? Sigma x0 is sigma h cosine to alpha. Alpha is a inclination, or we call it azimuth, and this is inclination angle. So when you apply this inclination angle to this relation, and then eventually put it in this formula, this is the reason why this is the showing that, you know, sigma r and sigma theta also is a function of alpha. Maybe you cannot see it here directly, but indirectly. So in that case, when alpha is 0 or 90, obviously sigma r and sigma theta is different.
We have lots of questions. We have 34, 35 more questions, and few questions are related to each other. So I think you will get your answers from the previous questions. Most of the questions are relevant to our next presentations. So I will not raise those questions which are related to our coming presentations. We are going to get answers from the coming presentations. So I will read few questions only. And if I miss your questions, this is my request to the participants. If I miss your questions, then you can write all the questions, you can send via mail, and I will get back to you with all answers. Okay, so next question is, in the last slide, it shows that the shrinkage is almost at the same pressure up to 40-degree inclination, while it is at lower pressure at more than 40-degree. But it also shows that it at higher pressure at 40-degree inclination than 0-degree. How it is happening? Sir, did you get the question?
Yeah.
Okay.
Could you, yeah, let me just, okay. So could you repeat the question again?
Okay, so in the last slide, it shows that the shrinkage is almost at the same pressure up to 40-degree inclination, while it is at lower pressure at more than 40-degree. But it also shows that it is at higher pressure 40-degree inclination than 0-degree. Pressure 40-degree
Yeah, that's,
inclination.
I understand. Yeah, that's right. Yeah, as you see that, yeah, it's a good point. As we can see that up to 45-degree, these are not changing that much. Eventually, yeah, the reason, you know, I should think about this one, you know. Obviously, this is the result of those mathematical modeling when you put different alpha in the equation. But physically, maybe the question is, what is the physics behind of this one? I should think about, analyze all these numbers, and then I will write. I will answer this question in writing, if you like, later.
Okay, so the same question you can send via mail, and I will get back to you with this answer. So next question from Savik Sen: which rock failure criteria you are using for coal? Which rock failure criteria you are using for coal?
Oh, yeah, that's a good question. I think I forgot the name, but basically, I should confess that this is the work from my PhD students. He applied different model for failure, and the failure criteria, which is now I forgot, but again I will answer this question in writing. This is good.
Okay, so we have another question from Dr. Puspa Sharma, Professor of Department of Petroleum Engineering and Earth Science, UPS. And question is, what is impact on borehole stability when drilling deviated well? I mean, what will be the impact on borehole stability if you deviate it well?
Yeah, that's again deviated well. If you want to look at it, depends on inclination degree. When you go more deviated, the angle is more than 45, and you close to the horizontal, the effect of shrinkage is even more, and you will have earlier failure than when you. So this is also the result. You can optimize your situation if you know this. If you apply this mathematical model, you know what is the best inclination angle, what is the best bottom hole pressure for production. So all this interrelationship between inclination and also pore pressure and drawdown pressure is available now, and then you can optimize your planning. This is my answer.
So next question, for Hughes mud loss condition, how stress analysis will change? For Hughes mud loss condition, how stress analysis will change?
Okay, obviously that is again during when you have a mud loss in natural fracture. Usually mud loss happens in a pre-existing natural fracture, and in that regards, I would say that type of depends on if you have natural fracture in shale or in coal bed methane. Obviously, this is the result. But in conventional reservoir, when the rock is like a carbonate reservoir, for example, if it is very strong, we may not have such a shrinkage effect, and so that is not. I would say I go with the no shrinkage case if you are asking about carbon reservoir. Yeah, that's it. Yeah,
okay, so there are some questions which are related to coal, and we are going to listen our next presentation on coal. So I'll be not asking the questions, but you can write all your questions via mail and you will get your answers. So next question, understanding the sinkage effect on coal failure due to stress, but it is depend on stress mainly, or other parameter are also involved like coal composition or depth. As we know that swelling affects more when there is a presence of CO2. In that case, what will be the measure taken by exploration company? What will be the measure taken by exploration company?
Sure, that's a important. It's a good question. I would say, when you analyze this shrinkage effect and also core failure, as I mentioned also that in addition to this stress changes, of course, this whole envelope is basically this friction angle and also intercept. We call it cohesion. Cohesion and this friction is much lower when compared to conventional reservoir. But for coal itself, as you said, when there is some other components like CO2 involved, that CO2 or any other material has effect on these, you know, compressive strengths of the coal. So I think we should know that not only stress and shrinkage effect has effect, but this is the envelope itself is changing to some other parameter of the coal.
So we have questions related to economy. I would like to answer that related to economy and policy of shale gas and CBM. You will get answer. We have one panel session tomorrow at 11:45. You will get your answer. And related to mineral composition, geological parameters of CBM, you will get your answer in the next presentation. So we have lots of questions, but we are running out of time. So I request all of you to send your questions via email, and I will save your questions also from here, and we will get back to you. So one question is, I want to ask about the slippage effect. Slippage effect.
A slippage effect, of course, we didn't go to that analysis. This is based on the failure, but that is also something that I would like to answer later. You know, we have published this work in SPE. I didn't
Okay, so
have the number. You know, you may have more information on that if you look at the whole articles that we published, and I will. I'm happy to share that article with you.
Yes. So sir has lots of publications. I think if we share the publications with the participants, they will get all their answers, and still they they have queries, then we will get back to them with via email. So I would like to thank all the participants and our speaker, Dr. Hagigi. Thank you, sir. It was an awesome session. Thank you so much, sir.
Thank you very much.
And okay, so till we join our next session, now we will have one polling. Can I request Harish sir to start the polling? Harish sir, are you there?
Yeah, done.
Done? Okay. So you will have one screen in front of you. Just you have to click audience. We just wanted to see how much participants are from academics, how much participants are from industry, and how much from research organization. Sir, how much time it will take? Or we can stop it, I think. No, all of them has not voted yet. Only, okay.
When you tell stop, then I will stop.
No, sir, 100 more participants have to. Okay. I think we can stop now, sir. So we have 74% participants from academics, 19% from industry, 2% from research organization, and others includes 5%. Thank you, sir. So now we will go to the next presentation. So I welcome Dr. James Peter. He is ex-GGM ONGC Videsh Limited. Dr. James Peter is presently, Dr. James Peter has a proprietary consultancy, that is JP Consultants. He is former head global exploration and senior executive vice president and group general manager of ONGC Videsh Limited. He has more than 37 years of hands-on experience in petroleum and coal bed methane exploration. He also worked as director oil and gas exploration in PT Petroleum Corporation Limited, and as director geosciences of Sun Terra Energy Services. He supervised all oil and gas exploration and production activities in Nigeria for Sun Terra Energy Services. He is MTech from IIT Roorkee. He is a DPhil and AAPG CPG. He was conferred National Mineral Award, which is very honorable award, and he received it in 2000. And Dr. James Peter will deliver lecture on historical perspective and present status of exploration and production of coal bed methane in India. So I would like to request Dr. Peter sir to start your presentation.
Thank you, Annapurna.
Sir, you
Good
can
morning.
make it PPT point, PowerPoint.
It's not coming. It's just not coming.
Okay, fine. You can start it, sir. If possible, you can
I'm trying to do it.
zoom in, sir. If you can zoom in. Yes, it is coming, sir. Yes, absolutely fine.
Okay. Good morning, ladies and gentlemen. As Annapurna just introduced me, I am Dr. James Peters, ex-ONGC. I've got my proprietorship consultancy, JP Consultants. I consult for conventional as well as unconventional oil and gas. I started the CBM exploration. I call it exploration because there was no development way back in '94. I continued that till recently, till 2014, off and on, and I kept going back to conventional hydrocarbons also. Okay, now I'm going to give you a very broad overview of what CBM is all about. Mr. Last Taude has already told us the importance of the usage of gas, especially in light of the climatic concerns, which again is a rather important aspect. And why is the government also trying to go back or go ahead for CBM? Okay, I'm going to cover a lot of things. What is India's gas requirements and sources? What is the historical perspective? And in this, I'm going to cover some fundamentals of coal bed methane. CBM reservoirs, what are the key parameters? Adsorption, desorption tests, which are very important for evaluating the resources as well as production. The different ways a CBM well can be drilled, depending on the subsurface geology. What are the logging solutions? Well completions. What is the type of CBM production we have? Then we go into economics, the viability of CBM projects. See, all CBM projects need not be viable, but under certain conditions, they do become viable. Then we come to the Indian energy scenario. CBM in India, categorization of Indian coal fields. Now, this categorization was done on the basis of data that was available way back in 94 to 2004, and we put up a paper in Oil Gas Journal where we officially categorized the Indian coal fields in categories 1, 2, 3, and 4, very similar to the petroliferous basins of India. What are the CBM resources and status of operations in India? And most importantly, we have to make a comparison between the US CBM scenario and the Indian CBM scenario. The reason is that US is the world leader, undoubtedly, and has a lot of experience in CBM. In the beginning, when we started CBM studies in India, we always took US, especially San Juan Basin, as an example. At that time, Powder River Basin and other basins were just coming up. Then we come to the pricing and marketing of CBM in India. You know, okay. Okay, you know, this is the primary energy consumption in India in 2017. Maximum obviously being coal is around 56%. Oil is around 29%. And gas is 6%. Yeah. And the rest is obviously nuclear, hydro, and renewables. Now, as per the vision, hydrocarbon vision 2025, the demand for gas is going to exponentially increase. In 2011-12, it was 330 million standard cubic meters a day. And in 24-25, it's expected to be 390 million standard cubic meters a day. Now, this increase in gas is going to be augmented by what? You've got CBM. Recently, our Prime Minister announced coal gasification, maybe a week or 10 days back. And then we have shale gas, which is again a very important non-conventional source of gas. So these are the different sources of gas, which is going to help us to augment the massive consumption that India is looking forward to. As per the Petroleum and Natural Gas Regulatory Body, or board, natural gas is expected to grow at a compounded annual growth rate of 7.2. It's grown from 2012 to 2030, right? So we've got domestic sources, which include CBM. We've got LNG imports, and then the cross-border gas. Now, cross-border gas, I think everybody knows, is the TPCL, that is the Turkmenistan, Afghanistan, Pakistan, India pipeline, which is in the process of being formed or set up right now. The gas reserves in 2017 stood at 106.58 million cubic meters, of which approximately 8% was from CBM. And it's shown out here. And the production reported in 2016 is from Jharia, A minuscule production. The operator is ONGC. Ranigan East, that's EOGEPL, SR Oil Gas Exploration and Production Limited. Ranigan South, Great Eastern Energy Corporation Limited, and Suhagpur West, Reliance Industries Limited. And the total CBM at that point of time in June 2016 was 43 million standard cubic meters or 1.456 million standard cubic meters a day. Now, the importance of gas is becoming more and more visible as we go into our development, India's development. But you will be surprised that the US has been into the CBM game a long time. The first CBM well was drilled way back in 1931 in West Virginia. And CBM was tapped from the Pittsburgh coal beds. It started commercial production in 1932. In the US, attention went to the San Juan Basin in 1950. And in 1960, a decade later, the Department of Energy from the federal government realized the potential of this gas, the CBM, because CBM was becoming more of a problematic gas for coal miners. They realized the potential of this gas to be an energy source. So they did a lot of funding for research into this entire game of CBM. And in the mid 70s, or rather late 70s, there was a field in Colorado, the Ignacio Blanco field. It started declining production. What the operators out there did was they fractured the coal beds they encountered in the vertical wells they had. And quite a bit of the production was supplemented by the gas coming out from the coal beds. 1977, Amoco Production Company drilled the first CBM well, and it produced 1,000 cubic feet per day. And since then, CBM has been in vogue in USA. Now, coming to the map, we have the San Juan Basin here. We've got the Powder River Basin here, the Piancet Basin out here, the Appalachian Basin here, and Black Warrior Basin here, Aracoma Basin out here. These are the main CBM areas, and the rest of the yellow part is the coal-bearing areas here. Now, the area, this area of CBM activity is very large in USA. It is approximately 331 square kilometers. And when I come to making a comparison with India, I will be telling you as to how big our operations are. And in spite of the difference of area, the Indian companies have made tremendous amount of progress in the CBM production, exploration and production. The global CBM resources are approximately 8,300 trillion cubic feet, and mainly from USA, that is around 1,700 TCF, and Russia is 2,800 trillion cubic feet. That's the main thing. India, when we started the entire game of CBM, we looked at it from a different angle. We did not have CBM related data. We just had coal data. Now, from that, we did a lot of theoretical work and we came to 1 TCF. That's about it. But then later on, as and when data got collected with different companies, obviously the resources continued to increase. And in 2014 and 16, it was estimated at 70 TCF, and by Marcellus, and 120 TCF by Caliphant. Caliphant obviously is from Advanced Resources International. Yeah. I think they are, or they were at one point of time, consultants to SR. Okay, like I was saying, we started our entire evaluation of CBM as a R&D project way back in 1992 at KDMIP. In 1994, we did some evaluation on Satpura Basin. Satpura Basin, obviously, I'll take personal interest because I had mapped that entire basin from 1988 to, from 84 to I think 89 or 88 or 89, I don't remember exactly. So while mapping this, we did map the coal fields in the southern part of the basin, and we realized that there are some good coal seams, and we did evaluate that in 1994. 1995, SR Oil drilled the first CBM well in Mehsana. They had a block in Mehsana, so they drilled the first CBM well in 1995. In 1996, ONGC drilled two conventional wells in the Raniganj Basin, or what we call as the Durgapur Depression, or which is the Raniganj East, which now has been awarded to SR Oil and Gas. We had drilled two conventional wells. We were on the learning curve. We really did not know what to do with these two wells. And some parameters were looked at, some parameters were evaluated, analyzed. And at the end of the day, we realized that it's not going to really suit a conventional oil and gas company to deviate to the CBM game, basically. But at the same time, in 1996, a year afterwards, we diverted our attention to Jharia Basin. Jharia, there's a Parbatpur block. We have got coking coal, very good quality of coal. And in Jharia Basin, the first well flowed on the 21st of August 1997 from Parbatpur, this thing. This well was drilled as a R&D well, and subsequently two more wells were drilled as R&D wells. And these wells are still producing. So you can imagine the potential of CBM in these small basins, small deep basins having very good coal. In 1997 itself, the Government of India formulated the E&P policy for CBM. And from 2001 onwards, the Government of India awarded 33 acreages for CBM exploration and development to eight different operators. So that's the status as on date. Now coming back to coal. Coal is supposed to be a dual system. It's a source as well as a reservoir. And source is well explained out here. You've got the coal rank, you've got from peat to meta-anthracite, and this is where the oil window lies. And this is what we're looking at, high volatile bituminous A, B, and C. And here is the gas in Raniganj. This is the gas window out here. While in Jharia, this is the, While in Jharia, this is the gas window out here. So the idea is that CBM, or the gas that is generated from CBM, is not released totally. Most of it is adsorbed on the coal seams. Now this adsorption will depend on the macerals. Coal has got different macerals. You have from liptonite to vitrinite to inertinite. There are three major macerals there. Indian coals are vitrinite to inertinite rich. And if you look at the microporosity systems of vitrinite, liptonite is oil prone. You look at the maceral composition of vitrinite. The vitrinite itself, if you see it on a scanning electron microscope and an EDX system, you are bound to see micropores in it, and that is where the gas is adsorbed. So we realize that 1 ton of coal can generate approximately 250 to 300 cubic meters of gas at peak production. Now, coal as a reservoir. As I just explained to you, coal is a source, and whatever source is, or whatever gas is generated, it gets absorbed on the coal basins itself, on the micropores itself, and you require certain parameters by which you can release this gas. The extra gas that is available goes in as free gas or gas dissolved in water in the coal, and the maximum is in the adsorbed gas, if you look at it here, out here. Now, I'll come back to this slide later on. So there are some optimized geological parameters for CBM. Presence of adequate quantity of coal at suitable depths, suitable grade, that means the ash content should not be very high, suitable type, like I've been telling you, vitrinite massive content should be greater than 55%. The vitrinite is the one which is going to have the micropore systems. Suitable rank, you'll have high volatile bituminous, volatile matter at 38% dry ash free basis, to low volatile bituminous with a 22% DAF. Vitrinite reflectance range is 0.8 to 1.7, and elemental carbon content would be 83 to 89% here. Permeabilities, very low. In situ permeability would be around 1 millidarcies, and the best if it is more than 1 millidarcy, that is greater than 3 millidarcies here. Then you should have sufficient gas content, and the degree of saturations is again an important aspect. You should have 80% under reservoir conditions. Now, how do you calculate the gas content? Even the very simple methods, laboratory methods. This is something that we set up a long time back at KDMIP, the Research Institute of ONGC. We've got dissolved gas, lost gas, and residual gas here. Whenever you take a core of the coal, this is directly measured. You put into desorption canisters and they are directly measured. Then you have a component known as lost gas. Now, this lost gas is that gas which is lost while you are lifting the core out of the borehole and putting it in the desorption canister. And finally, is the residual gas, which again is part and parcel of the total gas content, but cannot be released at very easily. It just remains in the coal. Now, talking about the absorption capacity, obviously is defined as the volume of gas absorbed per unit mass of coal in standard cubic feet, the volume at standard pressure and temperature conditions, this gas per ton. And this is an example from, again, I think this is from Raniganj, as well as from Bokaro. From Jaria. You have the adsorption isotherm working like this. And then finally, you should have the desorption pressures. That means you've got to depressurize the borehole to that extent where the gas can start getting dissolved. Which is obviously the fundamental rule to all production of CBM. So the parameters affecting producibility is gas content, permeability, hydrodynamics, tectonics and structural setting, depositional setting and coal distribution, coal rank and gas generation. So these are the aspects which will finally result in the producibility of this thing. So you've got to have an understanding of all these geochemistry, the mechanics behind the tectonics, the structural setting, the hydrodynamics, the permeability, then the deposition of coals. So all these things require a concerted effort. It requires an integrated approach. We have got many companies who have got people from different disciplines working together to come to what is known as the producibility of the CBM and how much gas can be finally generated. What is the reserves and resources and reserves? Typical coal is an apparently gas generative, has low permeability but good storage capacity. This is what a fundamental ideal coal would be. It should have generated gas. It would be having low matrix porosity, but will have a good storage capacity. That means we have to physically ensure that the permeability is enhanced here. How that is done will be explained in the next slides here. Now coming to the actual project evaluation, you got to have the historical data, geology, gather and evaluate all the data to develop a project, drill core holes, which again is very important. Obviously, we'll have other cores of coal, which will be subjected to all the desorption studies, the adsorption studies, the gas content, the dissolved gas, the residual gas, lost gas, everything. I mean, you have to have a number of studies on this system. Once you are very sure about the type of gas or the type of coals that are going to generate gas, and then some of your budget to go in for exploration test wells. Once you have the exploration test wells, you go to identify optimum areas based on selected criteria. You will have coal thickness, gas in place, which is the resource, then rock characteristics, coal capacity, which is the reservoir. Then obviously you have to have an infrastructure. You're going to produce the gas. If you don't have the pipelines, you don't have the group gathering stations, you don't have the pipe, you don't have the market there, you're not going to get your money back. So the idea is to have an infrastructure. That means the entire project area, the entire project has to be evaluated here. Then you've got the 5-pot well patterns. They're very conventional ways of doing things. You've got 80 to 40 acres spacing. And here is when you measure everything and evaluate results there. Once you are very sure that this is going to be economically viable, then you expand this thing. And if you feel that you may not be economically viable, you can always abandon the project. The government of India has given certain guidelines, as what I was discussing with Krishnendu just now, just before this session started. These guidelines keep changing. First guideline was made in 1997. Second was in 2017. And now I understand the government of India is rethinking on the entire guidelines for CBM activity. Okay, the new trends are the segmented approach. Evaluate available data, develop a segmented project model. Define priorities and select segmented areas for exploration, testing to derive data. The first part is just data collection here. Then you've got random selection of a number of core exploratory locations. In each segment, measure and analyze variable reservoir conditions. And within each recognized remaining segments, random selection completion of pilot production. And that is where we analyze the reservoirs and as an application on the 5-spot pattern that I just spoke about. Evaluate and compare results to analog basins or fields in the area. Comparison should be not from one end of the country to the other end where you've got different types of codes altogether. And then we go ahead and develop and abandon the project here. There are two examples I'm giving. One is segmentation based on reserves and resources. What is the proved reserves out here, the orange part, the probable, the possible, and the contingent resources, and these are finally the prospective resources. This classification is as per the PRMS 2011, and we have each area of this entire acreage developing into different sectors. Now, the segmentations or sectors is based on reserves and predicted peak production. That is what it's all about, And that is where you're going to understand where your fairways lie, where you intend to drill further, where you intend to produce the maximum amount of gas to get that value for the gas. Okay, the generalized CBM project life cycle has always been around 2.5 years of exploration, another 2.5 years of appraisal. Then we've got delineation around 15 years, not less than 15 years, and development, and then finally production up to 40 years. That means the entire life cycle for a CBM project is around 40 years, right from beginning, that is from exploration to abandonment. 40 years is a long period of time. CBM well drilling. CBM well drilling, conventional vertical well drilling with water-based drilling fluids. Then we've got underbalanced drilling with either foam or air drilling, air hammer drilling, and horizontal multilateral drilling. Horizontal drilling, a lot has been said by Professor NVP before this, and the stress conditions and all. But you should understand, coal is a soft material and has got stress issues. But having designed for all these stress issues, you can go in for horizontal drillings, multilateral, underbalanced drilling, and these are different alternatives. And the advantage is you have only 1 or 2 wells per section, simpler gathering stations. The environment impact is low. There are fewer pumps involved, no hydraulic fracturing, and approximately 5,000 meters of coal exposure per well. And that's a lot. If you drill a vertical well, you're going to only expose the thickness of the coal, whereas a horizontal drilling or a multilateral underbalanced horizontal drilling or a pinnet well drilling, you can go up to 5,000 meters of coal exposure where you can perforate and then you can produce from a larger area. Like the last point shows the high productivity wells up to 10 times to 20 times more than the vertical well grades. So that's the difference between the horizontal well and we've got different types of horizontal well. You can see out here one borehole, and you shoot off here. And these are the different pinnet wells. Likewise, out here you see a plan out here. And this is how a horizontal well would look like here. Then the next step after drilling you have to do for coring. You just can't go and perforate a zone without understanding what's there in the subsurface here. The logging, that is very important, is meant for CBM resource assessment, define coal thicknesses, gas content, sand and shale resource estimate determines the reservoir properties, resource potential, the shale, amount of shale and or sand between the coal seams, and if these shales or sands would have some additional gas in it, then your frac inputs, excuse me, fracture model inputs derive the input necessary for importing into the fracture model. And the type of logs are very conventional. Gamma ray, these open hole logs, temperature, compensated density, long space density, short space density, caliper, and caliper with density. And then you got the cased hole logs, which are gamma ray, collar locator, and cement bond logs. Now, this is an example of conventional logs that have been processed. And here in the processing, you've got all different parameters are understood here. Coal tonnage, the bulk density, the gas content, the lithology, proximate analysis of the coal, volumetric analysis, rock properties, and the coal gas in place. So that is also understood from the process data and the different stresses that are involved in the entire thing. So this is a composite log, which has taken conventional logs and reprocessed the information to give certain specific things for coal bed methane. Then we come to well completion. We've got different types of well completions. Initially, when CBMs began, and the entire game of CBM began, we used to look into different areas in the US. We never thought of Australia as, as an example, because Australia was also at that point taking off in CBM. Although Australian coals are more akin to the Indian coals, and they are both on the Gondwana systems. So we looked at a lot of data from San Juan, from Powder River, from Black Warrior, Appalachians, and we realized that fundamentally three types of hydrofracks: barefoot single zone open hole completion, multiple zone cased hole completion, single zone cased hole completion. They all given here the examples. This is a barefoot single hole of what we call as cavity completion. And this is a single hole perforation, cased hole. And these are multi-zone cased hole perforations here. Now there are, CBM is very different to production of CBM, rather, it is very different to the production of conventional gas. We've got different stages or phases. We've got the dewatering phase. Every coal seam has got water as well as gas. At the same time, if you had seen my earlier slides, you got to bring down the pressure in the borehole to the extent where the gas can start dissolving from the coal seams. Remember, the gas has been adsorbed on the coal seams. We've got the content of the gas through the adsorption isotherms. And now we are looking at the opposite, the desorption, that we got to the extent that we started. Now, to reduce the pressure, what happens is you're first going to have a dewatering phase. That means you're going to get the water out. Then you've got to start, and at the same time, you'll have some gas coming out. This is the water, and this goes down. And the gas keeps increasing up to a plateau stage or a stable production phase. And then finally, you come to a decline phase. Likewise, this is what is going to happen. Stage one is the saturated flow regime, where you've got only water. Stage two is undersaturated flow regime, where you have water and gas. And stage three is the flow regime, where you've got maximum is gas coming out along with the water. Then you got out here, you got the relative permeability to water. This is the curve. That means this is stage one, and it goes down like this. And this is relative permeability to gas. It starts off in nil and then goes up in this manner.
Sir, sorry for interruption. You have 5 minutes more for speak, and then we have to go for question answer.
Oh, okay.
Sorry for
give me around 5 minutes, 10 minutes more. Huh?
Okay,
right.
Sir. Okay.
Okay. Now, these are two real-life examples of production profile of CBM fields in India. Yeah, the blue one out here is the water and the red is gas. Okay. Then you have a breakout here. Now, just before me, Professor Hagigi was talking about coal fines. We had lowered a electrical submersible pump, a PCP, a progressive cavity pump, into the well. And we realized that the fines came in and it blocked the pump. So this gap that you see here is not, it is a man-made gap. It's nothing to do with the production curve. It is the pump was pulled out, it was repaired, put back, and again we started producing. And well, we got a pretty good, nice production out here. The number of days, you can see 0 to 100, 1040, 1400. And then you've got the different gas, and we went all the way up to approximately 25,000 cubic meters per day. This is another example. You have this as the water, the blue is the water, and this is the gas. This is a very typical gas curve, gas production curve, where I showed you, you have less of gas, more water, then you come to the plateau stage, and then finally you come to the decline stage. So all this is all going to go into the economic factors that you're going to look into for a CBM project here. Okay, now coming to viability, the viability of a CBM project is very essential. We have to fight against time. Critical number of wells in a minimum time frame. If we can't go on like a conventional hydrocarbon well, you keep drilling and drilling and drilling. No, you can't. You got to drill, finish, just move the rigs as fast as possible. So some companies use SRAM rigs, where it's easy to move, truck mounted. Critical volume of production in reasonable time frame. Then thumb rule is 100 wells with 1.5 thousand cubic meters per day. When it's close to the market, or 400 wells with around 6,000 cubic meters a day. You've got DJ stations, everything you have to have the entire infrastructure. So these are the basic thumb rules for a successful CBM project. It's time, it's money, it's the number of wells you can drill in the shortest possible time. As per what I keep reading the newspaper, SR has come out with a very massive plan. They've already drilled around 350 odd wells, and they intend going up to 500 wells to produce their CBM. Okay, coming back to the categorization of coal fields, we use the rank of the coal field, the maturity. What at that point of time, what was the dissolvable gas content? Does it exhibit dissolvable gas? The thickness of the coal seam, and the CBM specific data generated. You see, we were just, as people from the conventional oil and gas industry, we were looking at Coal India Limited, Geological Survey of India, Mineral Exploration Corporation Limited. We got different agencies working for, exploration. We look at all these people, we sign MOUs, get hold of data, just coal data, and then try to convert it to CBM related data. So on that basis, we had categorized the basins into 4. Category 1, Category 2, Category 3, and Category 4. You have the 4th category, which is rather low rank coal or lignites. Coming here, you've got the Permian coals, the Damodar Valley, it's mainly out here. Then Koil, Son, Mahanadi Valley is here. Here we've got the Wardha and the Sagreni areas, the Godavari Valley. This should have been Godavari Valley. Then you got the Mahanadi Valley. Then the Satpura Basin is here. Then Rajmahal Basin, again it's out here. Devgarh, Hazaribagh, Darjeeling and Arunachal, that comes up here or somewhere. And then you got the tertiary coals, the Garo Hills, Khasi, that's all in the northeast. except for Naveli. Naveli is down south here, North Gujarat and Rajasthan. This is where you get the lignites here. So like I told you, we have categorized Jharia, East Bokaro, Raniganj, North Karanpura as category 1, or the best candidates for coal bed methane. Then category 2 is South Karanpura, Rajmahal, Sawarpur, Penchkanan. Penchkanan is the Satpura coalfields. Then category 3 is the Pranita Godavari, Ib River, Talchir, Wardha. And category 4 obviously are the lignites, the Cambay Basin lignites, Rajasthan, Jammu Kashmir, and Naveli. Okay, now I'm not going to go into details. This is just a summary of what is there happening. CBM resources in India is approximately 1.4 to 2.6 TCM. And the initial area that has been allotted for CBM activity is around 17,000 square kilometers. Now remember, 17,000 square kilometers compared to 331,000 square kilometers in the US. Enormous difference. But like I said, in spite of the smaller areas we're dealing with, some of our companies have made very good progress in CBM activity. That's GECL, SR Oil, ONGC, Prabha Energy. Prabha Energy is 25% shareholding in one of the ONGC fields, basically, and they are the operators there. And out of this, we've got around 12% which is under development, or they've entered into phase 3. And there around 17% of the area, phase 1 has been completed. Unfortunately, we've got 60 odd percent of the area which is being relinquished. And a very minuscule amount where the petroleum exploration license is still awaited. And there is a dispute on one of the fields that's around 4% here in Manargudu, which is basically down in the Naveli side, because I think 79% of the, or 79, or I don't remember exactly, certain large amount of percentage is lying with the conventional oil and gas people, ONGC. Coming back to what I said in the beginning, we have to make a comparison. Geological and engineering models are in variance between US and the Indian CBM scenario. USA, like I said, most of it was re-engineering projects. They recognized very early in time that the gas being emitted from coal seams are an hazard to the miners. So it is better to convert it into energy, a source of energy. USA had the existing infrastructure and industrial support, the proximity to area, very large areas of operation. And in India, the prospective areas are small compared to US basins, meager infrastructure and difficult logistics, front-loaded capital and technologically intensive, and looking at the different economics of scale. I think this should be my last slide. Now, the successful operators, ONGC, Prabha Energy Private Limited, or ONGC, in North Karanpura, ONGC in Jharia, EOGEPL, East Raniganj, EOGEPL, sorry, the mistake out here. This should have been, okay, sorry, it is okay. EOGEPL, this is the latest information I just recently got here. GECL, Great Eastern Energy Corporation Limited, South Raniganj, and Reliance Industries. The blocks of Bokaro, I've already read that. The mode of distribution is direct. ONGC gave it to Messrs. H and Roy. The value of CBM at that point was 5.77 US per MMBTU. And gross calorific value is normally taken at 85%. North Karanpura is being given to GAIL, that is the Urja Ganga pipeline at 5.56. Jharia, they are selling part of the gas from Jharia to a private company known as Positron. Positron has tied up with another bottling company, and they use the different cascades to transfer gas to different parts of the eastern part of India. They're selling it at the rate of 6.12. East Raniganj, again, Urja Ganga pipeline. That's the pipeline made to be the same by GAIL. We have got Matix Fertilizers, which is the major client. But what I understand from public information is the Matix Fertilizers, they basically are yet to start full production. Graphite India Limited, Philips Carbon Black, Ritesh Trade, Fins, etc., etc., etc. They are selling this at $7.1 per MMBTU. And they are also recently looking at CNG. And the Urja Ganga pipeline, they are selling it at 8.808. That is to GAIL. And I understand they've entered into a contract, or they're about to enter into a contract for next 15 years that all the gas will be given to the Gas Authority of India Limited at 8.08, which will be a massive profit or recovery for SRI. Okay, then we come to GECL. It gives it to different industries at 10.4. And Reliance Industries, Swapur, it's giving it back to its own affiliate at 7.15. There has been some issues with this. Okay, thank you.
Thank you, sir. Sir, we are getting lots of comments and questions, and they are really liking your presentation. We are getting comments like fantastic way of explaining, Peter sir. James, simply amazing. So we are getting lots of comments for you. It was this presentation was very helpful for my academics. So we are getting lots of comments for you, and sir is definitely a wise person, and sir can speak for hours and hours, but still we have to we have some time limitation. And I know sir since last 10 years. Sir is not only my professional guide, sir is a philosopher, and sir is a sir provide very inspiration. Thank you so much, sir. So we will take few questions now. Now we have limited time, so we'll take only few questions. And my one announcement to all the participants, as we are getting lots of questions, more than 50 questions. We have 72 questions now. So we cannot answer all your questions. So what I am planning, I will send one Google form to all the attendees, all the participants. So after the workshop, you can write your questions to specifying the speaker, and I will get your all questions. Then we will come back to you with all answers. Okay, so now I will take few questions. Which is the most cost-effective mode of LNG transportation at present?
Mode? Or do you want it pricing wise?
Which is the most cost-effective mode of LNG transportation at present?
At present is best is by ship. You get you got the Qatar long-term.
May I take the question, sir?
Yeah.
So my point is that, see, in China, there are some LNG coming in from Russia, which are in terms of road transport by truck LNG.
Okay. No, I have not seen it from that point.
Yeah, so but the main factor remains that as of now, it is mostly, if you see the Australian eastern coast, the high price of the Japanese crude consumption is very good for them to send it by shipping transport. So there is only one answer to this. Yes,
yeah, please go ahead, Krishendu. Hello.
That is the best option to. Yep. Am I audible?
Yeah, absolutely.
Yeah. So yeah, that is the answer basically. You know, if you are talking about LNG, shipping is the best option. There are some Chinese road transport happening, but they are not cost effective.
Okay, thank you, sir. So next question is whether coal bed methane is restricted to the bituminous coal only, or it can be found in lignite or anthracite deposit also?
even lignite generates gas. There's no doubt about it. Yeah. But because of its properties,
yes, higher mature anthracites are
valuable amount of gas. Yeah. We have done. You see, when we are in the ONGC, we did for Barmer. Am I audible?
Yes.
Yes.
Okay. We did for Barmer, and we drilled along with GSPC. We did some drilling in one of the rounds of CBM only. We had to give it back. We had to return the block because it was not really viable. Everything is not too good as far as lignites are concerned. Yeah. Then another thing is the Manargudu I was talking to you about. It's been taken by GECL, I think.
GECL,
right?
yeah.
And it's the problem there because they say most of the areas, they are with this thing. With ONGC.
So regarding lignites, there was one question, Annapurna, I saw, which was regarding Mehsana.
Yes, yes.
Okay.
Is developed for CBM?
It's not so far because
no, that's not been developed.
As sir was telling, we have done our SR has done the first wells in the
first
year
wells 85, 95, yeah.
93, 95. So and that test proved also, but unfortunately, there are some issues in terms of exploiting the gas at that point. So now, as we speak, we are in advanced stage of negotiation with the government of India for starting exploration in that block. Apart from that, we have done an evaluation of the surrounding fields in terms of what is the CBM potential. Mostly, Peter, they are ONGC MLs.
Yeah.
So that gives us the right to in the August 18 policy. So we have also evaluated that, but that would take some time because all these are producing blocks.
You see, I'll tell you the fundamental technical problem here. You see, these coals, they are basically associated with oil-bearing horizons. Now, the basic fundamental issue between coals, like I was telling you, got to desorb it. That means you got to lower the pressure. And that lowering of the pressure is going to interfere in your oil production. Now, what would you want to have, the oil or would you want to have the coal? As a businessman, I would like to have the oil.
Absolutely, yes.
I would think of gas later on, First, let me deplete the oil. You see, I gave an example in the 70s. In Colorado, they had the Ignacio Banco coal field where they depleted, the oil was in decline. They had coal seams, they perforated the coal seam because the Colorado laws, the regulations, does not differentiate between coal bed methane or the conventional hydrocarbons. It's the same, it's a source of energy.
Okay, sir,
once we have that mindset, then things become different here.
Sir, we have lots of questions on Jharia coalfield and Parbatpur block. So can you give some insight on commercial prospectivity of these two areas?
Please.
Jharia and Parbatpur.
No, Parbatpur is part of Jharia.
Yeah.
Okay.
It is Parbatpur. You see, what has happened is, I'll tell you. Parbatpur block. Yeah.
Yes.
It's a part of Jharia coalfield.
Yes.
And I'll just let me give you some history base. The Parbatpur block belonged to a steel company. Okay. The steel company could not mine that block because it's a small area, 18 square kilometers, and it has got around 32 faults in that. Having 32 faults in that area, it's really impossible to go into, mining that block here. So they negotiated with ONGC and ONGC took it up as R&D. That R&D used to be expendable in the budget of ONGC. So we took it up as R&D, and we drilled 3 locations, and they gave very good results. Being sold to Positron, who's selling at, how much Positron is selling at? $15 to $18 per MMBTU.
Okay. So we have to end this session because we have another speaker to deliver lecture, and we have limited time. We have lots of questions. 93 questions are coming. So I request all of you that I will send a Google form to you, and you can write your answer to specify to whom you want your answer. So a lot of questions on lab analysis of coal adsorption, desorption. You will get your answer. We have tomorrow one speaker, Dr. B.A. Mende and Dr. Prusti from IIT Kharagpur. They will be delivering lecture on specifically on this adsorption, desorption mechanism. So I would like to thank you, Dr. Peter sir, and all participants. So we want to start our next presentation.
Thank you.
Thank you, sir.
Thank you, Annapurna.
So I would like to welcome Dr. Krishnendu Chatterjee. He is Joint General Manager, SR Oil and Gas Exploration and Production Limited. Mr. Chatterjee is presently part of the International Strategy and Business Development team of SR Group and also leads policy and regulatory affairs. He has around 16 years experiences and well known across upstream oil and gas sector. As a geoscientist, he played a lead role in the commercial discovery of CBM in Raniganj coalfield and Mehsana lignite. He is a master in applied geoscience from IIT ISM. So, sir will be delivering lecture on accelerating development unconventional hydrocarbon. Please, sir, you can start your presentation.
My screen visible in a full screen or?
Yes, it is visible. You can put in PowerPoint mode. It is visible, sir. You can put in PowerPoint mode at the bottom.
Okay.
Slideshow.
Yes, yes.
Yeah, it's okay now?
Yes, slideshow. Thank you, sir. Yes.
Yeah, so good afternoon, panelists. Good afternoon, sirs, teachers, students. It is a nice opportunity to speak, and it was quite exciting the way Dr. Peters was mentioning the development of CBM industry. So what I will try to do is I will try to take you forward from where he ended at the status note of CBM. Now, going forward, there is one thing that we need to think over, which we have been doing for some time now. Despite a legacy of more than 25 years of exploring and trying to find out CBM development in India, why it has not happened. So what I will try to give it is time perspective in terms of where we are right now, whether it is possible that we can consider this point, we should be kickstarting the CBM development in India in an aggressive way. That is one. And the other thing is that what has been the bottlenecks? So what are the bottlenecks and how we can address that in terms of getting the actual CBM development into the map of India. Now, the first, before I start, I want to say one thing. That if you go back to the history of oil and gas for the last 150 plus years, you will see the development of gas, because we are kind of in CBM industry or shale gas for that matter, we are commonly called as gas enthusiasts in the industry. So we would try to bring a picture where we think that gas is probably getting more important in energy basket, because the way it's happening, because of the way the resources are developing, and because of the way it is getting clean an environment for us, as our MD was referring, lead us to the hydrogen scenario eventually. So now if you go back over the 150 years, you will see that gas initially was termed as associated gas. It never had an independent basket for itself. Till these big finds that happened, the gas finds of the USSR, now the CIS, the gas finds in the Middle East, Qatar, Iran, the gas finds in Eastern Africa and offshore, of course our own Mumbai offshore, and then going forward farther east, we have some big gas finds. So now I go to the first slide that I have. This is the track of the entire oil and gas industry of the last 50 years. So as you see, there are three myths that have been broken across the time. Myth number one was, yes, gas can be coming up as an independent resource on itself, which has already happened. But the other thing was whether unconventionals are going to happen. So if you see this curve here, if you see the development trend, this is a slide from the IBM. So if you see the slide across from the east, from the left to the right, you will see that starting from 1977, where the CBM development started in the US, there are a lot of changes happened over the time. And from 2006, there was a net development of US share, as you see. And eventually what happened is by the beginning of this year, before COVID-19 happened, they were probably going to lead the market in terms of unconventionals, and that they are right now. Unfortunate part is this COVID-19 has happened, they have slowed down slightly, but yes, as a matter of fact, if I go by the history, you can clearly see the unconventionals is a source that has broken the myth. It is a genuine commercial process of discovery. It is happening. The other myth is whether CBM is equally possible. Now, I will draw your attention to this particular set of buildings here. If you see, this is the LNG export across the various countries, what has happened. So if you see in this one, you'll see that till 2019, the year ending, Australia and Qatar were mostly equal in terms of the LNG exports, around 77, 78. If you go to 2020, by the original forecast, if I leave alone the COVID-19, then Australia was overtaking Qatar. And mind it, all this gas that is coming into the LNG from Australia mostly are coming from the eastern coast, where they are having these prolific CBM developments, as Professor was referring earlier from the Pavan and the Surat basins. So this actually puts the fact in perspective that yes, CBM development can also get you a commercial and a wide scale entry into the industry. So that is already happening. Now, if you see the donors here, they are a 10-year lag of 1999 and 2019 in terms of the reserves of gas. So Australia has achieved this in terms of CBM, but if you see this yellow one, this is the share of Asia Pacific. The Asia Pacific has not gone up much. So there is a significant scope of development of putting, these are the reserve ones, so there's a significant potential of the resource that we have to go into reserve category. And that would in fact change if you see a next 5-year lag, 5-year forward, then you will see that as unconventional has grown significantly in that mix. So now, after we said that, now what the situation as of now is in the oil industry is like this. What has happened is there is a serial demand and price destruction that has happened, which all of us know. WTI price was negative in the month of April. So this is what the scenario is as of now in terms of a point forward for what the oil industry will do. Now, there are two things that I want to point out here, that the oil industry is not going to recover over the next at least 2 to 3 years. On the contrary, the CBM in the LNG industry, the gas industry, they have survived a low of around $2 per MMBTU of gas, and there are some projects that would be delayed in terms of liquefaction, but it is a matter of fact that gas is going to be a big chunk of investments over the next few years. On the contrary, if you see this one here, this is the investment in the overall E&P industry. There's a steep decline that is expected in the next couple of years due to the current scenario. If you see, there are two scenarios here built up. One is the effective regenement of the virus, where the demand goes up. It's a V curve. And then there is a mitigation curve, which is also going up. But having said that, the levels of 2019 and the price of 2019 are some time away. There might be some reports of JP Morgan saying $100 is possible, but that would be a cyclic limitation. It would not be easy to come. So another thing is that there's a lot of things happening in terms of making crude oil a non-incumbent source. So you don't have it as a preferred choice, number two. Number three is that if you see the gas, it has a wider spectrum of usage in terms of the households, in terms of the industry, in terms of, on the contrary, the oil use is mostly restricted to automotives and aviation as a major chunk, both of which will take some time to recover. So having said that, we are in a position where the crude oil is going to gradually be slightly on a lower tune, while gas is going to have a significant build-up over the next few years. That is a perspective that we have from the various reports that we are seeing around us. In fact, I'm not sure if anyone of you followed the Credit Suisse convention in Australia yesterday. There was a remarkable statement that yes, now the gas industry is delinked from oil and gas, from oil industry. They have their own trajectory of development now, which is a very unique thing that they are saying. Now we come to one place where we are giving you a natural gas outlook over the next last year basically. So what we have is in terms of you can see this thing that there's a growth of around 5% over the last year. Then there is a lot of infrastructure and LNG and pipelines scheme that has come over the last year. The prices have gone down. It has two impacts. One, the price going down means that the gas industry as such will develop. The price going down, on the other hand, for upstream operators means that we have to be cost competitive. Then the price of regional natural gas hubs, starting we have the National Balancing Fund in the UK, going all the way up to Japan, there is a severe fall in the hub pricing. And then the long-term effects of natural gas on due to COVID-19 is that a lot of LNG final investment decision will be delayed. So what is going to happen is that by 2024 there would be which we think is going to trigger a lot of activities in domestic gas securitization. We already are in that mode that we are having a vision of 10% import reduction dependency. So that is falling as a part of that same bracket. Globally also we are seeing that a lot of domestic gas supply security is happening. So now natural gas, this is a slide which we have taken from the IGU, International Gas Union. So they say the gas development will be happening in 4 different categories. These are all for policy makers as well as policy stakeholders like us. So the basic outline is that there is a clean environment coming out of natural gas. So what it creates is it creates a cleaner air in the macro level. Then it improves the lives across the users. Then from the user perspective, we again go to the lights on. That means that these resources are so high, which I will cover in the next couple of slides, that there is a possibility of another 250 years if the gas industry is going at this stage of gas, ample gas is there. Now the fourth thing, which is most important, is drives energy solution. A lot of innovations are happening both in the LNG space, in the pipeline space, and in the upstream space, where we are going into a lot of innovative ways to reduce the cost and get gas into the stream. And other thing that I wanted to point out is the latest diagram from the BP Outlook 2020, which came out last week only. You can see there is a steady fall in the crude as well as the coal supplies. With the natural gas and renewables, the renewables are far behind in terms of the percentage. So they are steadily growing up. So can we just think that over a period of the next 7 years, gas will eventually reach the levels of oil, though there might be chance oil can again recover and come back to the original upward curve. But the non-incumbent scenario, like we don't prefer a lot of oil going forward, would probably bring the gas on the upper segment compared to crude oil. So now coming to drivers. What are the drivers that would take us to a natural gas development? Now I will gradually come to the next level of focusing into a territory, geographical territory. So the drivers that we typically mention is cost competitiveness. So we have to be cost competitive. Price of around $3 per MMBTU would probably be the best that can keep us alive. Security of supply, that means that the customers who are getting gas would have a significant amount of comfort factor that they are going to get gas at a sustained volume over the time. What the upstream operator on the converse would need is a lot of infrastructure to deliver the gas to the customers. The third thing is sustainability and policy. This is very important. It means that over the course of the next, we have a commitment towards COP21 and COP24 as of now, and all other countries, particularly the European countries and the Asia Pacific. So all of us are going forward to a place where we have to work something out to bring a more sustainable environment. So gas is one of the things that can do that. The other is policy in terms of how the government can play a role in that, in terms of getting more attractive policy and more attractive fiscal regimes to make that happen. Now, this is again another snapshot from the BP energy scenario, which came out last week, which sees that there is a steady growth of natural gas going forward till 2040. And the Indian scenario is we are talking about a growth of natural gas 6% currently, 15% by the year 2030. That is a vision that we have already been working on. All the companies are working on that. So, and that is a basic thing to take care from this slide, is that we are going to a future of gas-based economy. So what is the current scenario of natural gas across the globe? If you see, the dark reds are the one which are having a lot of gas and using a lot of gas. So if you see, there is a credible development happening in the Asia Pacific. There's a lot of area that we can work on. There's a lot of demand of gas coming up. So this area is going to be the key in getting you one place. So from the global perspective, now we have come to the Asia Pacific perspective. This is a perspective of how the LNG is moving and the pipeline gas is moving across the globe. So if you see, the Eastern Australia, as I was mentioning, is having a steady amount of production of CBM gas into the stream, which is going to Japan and Korea. Apart from that, there is a gas coming from Qatar. Apart from that, there is gas coming from Russia. As I was saying, from Russia to China is also happening. So all these things point out to one thing, that there is a huge demand of gas in the Asia Pacific region. So probably at this point, we can say that this is the scenario, this is the time that we have been looking at, where we can look for a time where CBM can actually come into the picture, at least in Indian perspective, in China, because the domestic gas sector has to be developed. In this scenario, what happens is, in the LNG scenario, by 2024, a lot of the investments getting ticket in the LNG terminals getting commissioned, what will happen is there will be a supply shortfall. So the natural consequence is that it has to come from domestic gas. So domestic gas in Indian perspective is very difficult, because I will come to the in the next few slides on that thing. So the last one I want to say here is that if you see in terms of the resource perspective, this is what the global scenario looks, the reserves. So if you see, there is a equal amount of conventional and unconventional gas in the Asia Pacific. There is a significant, around 30% amount of unconventional gas in the overall global perspective. So there are two areas that we can see is a development possible in terms of gas, unconventional gas. One is this, which has a credible reserve now, and the other is Africa. The Africa, as we know, is slightly cost competitive now. There is a lot of conventional resources that are like untapped. So it will take them some time. But as far as Asia is concerned, since we are the third largest economy in terms of energy growth and energy consumption, so India, China, these countries are going to drive a lot of things in the near future, where we can have some domestic gas definitely required to come into the stream of production. So why do we have a focus on unconventional gas, as I was saying in the last slide? So the Asia Pacific, primarily Australia, China, and India, the countries are going to drive the gas domestic supply. And the other thing that is more important is, all these three countries are very similar in terms of the energy pattern, and very similar in terms of the CBM development, though they have started early, slightly early than us, and they have gone at a steady rate. We have been able to go at a slow rate, but yes, we have some learning curve in place now, so we will get some benefits out of it. So the unconventionals will grow in the Asia Pacific is the key tenet that is coming out of that. So the myth number 4 that we have to break here is, unconventional gas in Asia Pacific is possible and it is happening, and it is resource and volume supported. So what is the price trend we have? This is the price trend that is from Rystad Energy. We see the spot price of LNG is gradually stabilizing around 2.5, and crude link price, as we see, is hovering around 4 to 5, but it will go up as the crude price also goes up. And there's a tendency of more of these contracts. In Indian LNG contracts are all of 2028. So we see that a lot of contracts are long-term contracts. So there would be a chance of many contracts that will be renegotiated, like the Petronet, like the GAIL, to getting into more competitive environment of around $2.5, which is the scenario. So this price is slightly high, so there is a chance of renegotiation also of the contracts. This is another slide from another snap from IHS, who say the same thing, basically, just to give a comparison that the forecast is more or less similar. I have put this thing. So the scenario is very much similar. As we go up to 2021, there is a steady increase of the gas price. There's a steady increase of the demand. But unfortunate part is, at this point, there would be some delay in the LNG plants, which will happen over the next 3 years. So there would be a supply shortfall coming up in the next 3 years. So let's take a look at Indian ENP, how it looks like. So we have 600 active acreages over the NELP and nomination blocks. We have 8 active CBM blocks, which Dr. Peter already mentioned. 400 nomination acreage out of the 600. So you see the scenario is still NOC dominated. Both oil and natural gas production has more or less stagnated. You can see this curve here. It is not having a spike in any place that you can see. No major FDI has happened over the last few years in terms of investments. Expanding gap, expanding imports, of course. No major discovery has happened. The KG discovery was there, but it has been not able to live to the amount that it had projected. The help rounds are happening, as we say. A lot of there are 5 rounds have happened in OLP and 1 in DSF, 2 in DSF. But the results are sometime away, because once the thing starts and the things start to operate, it will be sometime till they come online. Stagnation of reserves, and both in terms of oil and gas. 4.7 billion is a number in terms of oil. 1.3 TCM is a natural gas, and these are not including CBM. Best practices, the GIPIP, global practices that has been launched, is already there. Policy framework, unfortunately, we still stand in a scenario where it is strongly regulated. Operationally, it is multi-regulatory control. Not only we have controls from the central, it is also from the states, as well as from independent agencies like PNGRB. Fiscally, there is on an average plus 50% offtake that goes to the government of India. There's a limited amount of subsidy in the upstream. Exploration activities showed there's been a lot of slowdown in the activities due to a lot of clearances required. So coming to CBM and Shale, what is the current scenario? Third largest economy that's there in terms of energy. Heavy imports, we are importing around 60% by LNG. There is an import reduction of 10% by 2022, which is the vision that is we are working right now. The country is working on that towards now. Natural gas growth up to 15% by 2030. Strong policy support is required, and there's a lot of infra support required also, like pipeline and the gas is already in place. And the pipeline expansion where it's happening, but it's on a slightly slow pace. Resource support is there, nothing wrong in that. Gas 100 TCF as per EIA, the last report they had. CBM resources 92 TCF. Apart from that, there is another equal volume that is coming up in the Coal India blocks. The Coal India has been given the right in 2015 and 2018 to start Operation India blocks, the hold in terms of coal mining lease. They have already come up with 2 blocks. So that is one thing that we're looking forward to, how much it develops, how much of this 100 TCF converts to actual reserves. The status of CBM is, yes, commercially discovered now. There are 3 blocks. Encouraging shale gas results from a few wells in various basins. 50 blocks by ONGC and oil, and 6 blocks for Oil India has been targeted. They've already done that. They have in a staggered pace. I will come to that. Coal India, CMPTI, and GSI has some activities in Damodar Valley coalfield. So I would like to make another point here that Damodar Valley coalfield is one of the areas where you can find both CBM and shale gas. Very interesting coexistence, and there is a lot of prospects in terms of going forward and developing into one of the major basins of, if you can say, the eastern unconventional basin. It has a huge potential to develop. Then CBM, generic overview. I think there are these 2 curves here, which are till 2019, what are the production that's happening. So in terms of, there are only 3 blocks, as we know. Dasar, Naniganj East, GECL, and Suapur West of Reliance. Going forward, there is a curve by IHS. It says that the 2 more blocks come into picture, North Karanpur and Bokaro. But if you see, the overall accretion in terms of per day production is not that high. It's more or less, in the range of 3 to 3.5 MMSCMD. So what is the industry looks like? CBM policy in 97, blocks from 2001, 33 blocks have been awarded. More than 50% have been relinquished or under relinquishment. 3 commercial blocks in the curve that we saw. Total about 10 TCF has been discovered. Total investment in excess of around $2 billion so far. Now the outlook is the industry is slow, as we can clearly make out, because the activities are mostly focused on development. There is limited exploration activity happening. There have been 5 blocks which came up in OLP4 of Government of India last year. Unfortunately, no one bid for that. There's a price slump since bidding is an important point. The bidding, when it happened, for example, our block, the price focus was around $8 to $9. Over the years, it is around $3. So there's a lot of slump of happening, and in terms of economics, a lot of things has to be recalibrated. CBM is a non-incumbent energy source. Why? Because they are mostly in coal belts where coal dominates energy scenario. You will get more comfortable and more access to coal than a CBM project. That is the common mindset, which, as James was referring, that due to the coal gasification policy that is happening now, there would be something of a remarkable change that is slated to happen in this thing, but we have to wait and watch. So then again, the other point is infrastructure strained. There is no infrastructure support in the areas that most of the operate. Reliance had thankfully been able to access the pipeline, and you see the production has gone up. We are producing around 0.6 MMSCMD now. The reason is that the pipeline that is coming, the western east connectivity, Ruja Ganga pipeline, is some months away. And once the pipeline comes, then we will again ramp up to the production volume of around 1.6. That is the plan for the 350 wells we have. So what is the takeaway? That there is a genuine requirement for reforms. Shale, NOCs have done some activities. Other agencies have done some activities. The scenario is that there's not much in terms of actual activity happening right now, because at this stage the investment is slightly slowed and no one is comfortable of an investment in shale gas right now because of the amount of investment, A, B of the gas price, and C of the scenario of gas developing in the near future. I think idea is that we will get sustained in terms of the existing CBM and then we go into shale gas. But the good thing is that both the help and the 2018 simultaneous policy, which was launched, has opened up the entire country. As James was referring, that the entire country is now opened up for undertaking CBM and shale gas, wherever there is a potential in terms of category of basins or in terms of finding a new source. So what are the infra and policy initiatives over the last, till the announcement of the last policy, 1997 CBM policy? There has been one policy in 2007, which came in terms of giving extra timelines for delays in clearances. There was one policy in 2017, which was landmark policy, giving you pricing and marketing freedom. Then there was one on unconventional hydrocarbon 2018 policy, which is giving you access to all the unconventional resource in a vertical space. Then there was a guidelines to NOC for doing shale gas in 2013, which they have already done. So there was a policy framework for EOR and IOR, enhanced oil recovery, in which unconventional has been included in that, though not CBM. And then the other thing which is most important is infrastructure scale up. So we have a national pipeline expansion, which has to be expedited. And we have a launch of the international gas exchange, which has already happened. But the modality and the access is again dependent on the ability of the pipeline. So what are the suggestions that we are trying to promulgate now? A lot of I think there are some of my friends of DGH already in the participants. So there will be presentations on these lines, I guess, from DGH tomorrow. But the industry is very upbeat in terms of demanding certain changes. So I would take slight pull back to what Dr. Peters was saying in terms of the basin categorization. So in OLP, they have put a category of basins in which it says that it is on the basis of the amount of chance of commercial discovery and whether there is a contingent resource available in any block, in any area. So based on that, they have both yes, one, contingent discovery there as category 2. Category 3 has no contingent discovery and has no commercial chances as of now. So we say that CBM and shale gas can be put in category 3. This has a direct fiscal benefit because the category 3 basins have been exempted from any fiscal commitment at the initial bidding. So this will take a long way forward, a leapfrogging for the CBM and shale industry, that they would not be bidding for a block without knowing what is going to come out of that. They would go for exploration bid. If there's a windfall gain, eventually when the block starts to produce, then of course a modality for getting into a fiscal model can be worked out. Then we have done a couple of collaborations with the universities. So this is a very important thing. I mean, this is one thing that we have been telling, and we have been a lot of activity we have been doing in this, getting engaged with the universities, the government of India, and the other agencies in terms of a collaborative platform. You see, there is MSOP model of data generation in the DGH, in which they give the access to data to the companies who generate that, which they can keep hold of. So can we not work towards a model of where we can have this platform engaged in generating data in the broader area where there is no data and where there is chance of a discovery or the chance of a development of CBM or shale gas. That way, there would be a data generation, there would be some incentives, there would be a transparency of data. So then, of course, there is a simplification of process, which they are already working on, as I understand. Allow flexible gas marketing of this IGX has come up. So we have to make certain changes in the policy, in the framework, to allow our operator to also sell into the IGX, apart from the fixed sales that they have. Support and removal of holder ceilings. There's a lot of issue in terms of land. As you know, Australia has a lot of advantage in terms of huge parcels of land they are able to access freely.